Hello guys, welcome aboard Apex Math. My name is Pino. In this video, we go through question 3 from the 30th July 2025 N5 Mathematics question paper. Question 3.1, we are given f of x is equals to x cubed minus 2x squared plus 4, and question 3.1.1, we determine the coordinates of the turning point of f of x. Now, suppose that we had a curve, and at the turning point of this curve, at that turning point, the gradient is equals to 0. The gradient is equal, the first derivative, and it's equals to 0. So to determine the turning points, we are going to differentiate the f of x and equate it to 0 and solve for x. So let's differentiate this f of x. So the derivative of the f of x, the f prime of x, is equal the derivative of the x cubed, which is equal 3x squared, and the derivative of the negative 2x squared is equal negative 4x, and the derivative of that 4 is equals to 0. And we equate this to 0 and solve for x. So we have 3x squared minus 4x is equal to 0. Let's take x as our common factor. So we have x into 3x minus 4 is equal 0. Now, x is equals to 0, or 3x minus 4 is equal to 0. We have 3x is equal 4, and let's divide both sides of this equation by 3 so that we can solve for x. So our x is equal 0, or x is equal 4 divided by 3. We have to substitute this into the original f of x equation, not the differentiated equation. That original equation, that's where we substitute the x coordinates of the turning point to determine the corresponding y coordinates. So we start off by substituting the x is equals to 0 where there is x. So we have f of 0 is equals to 0 cubed minus 2 multiplied by 0 squared plus 4. So our f of 0 will be equal 4. Now we determine the corresponding y value for x is equal 4 over 3. So f of 4 over 3 will be equal 4 over 3 raised to the power 3 minus 2 multiplied by 4 divided by 3 raised to the power 2 plus 4. So f of 4 over 3 will be equal, so this is equal 76 divided by 27, and in decimal form this is equal 2,81. The coordinates of the turning point, we have when x is equal 0, y is equal 4, and when x is equal 4 divided by 3, y is equal 2,81, and this will be our coordinates. Question 3.1.2, we draw up a table of x and f of x where x is ranging from x is equals to negative 2 to x is equals to positive 3. For this question, we just substitute the integer values from negative 2 to 3 where there is x. So we have f of, so we start with negative 2. So f of negative 2 will be equal negative 2 raised to the power 3 minus 2 multiplied by negative 2 squared plus 4. and on our calculator, this will be equal negative 12. We substitute negative 1. Negative 1 minus 2 plus 4 will be 1. We substitute 0, so this will be equal 4. And when we substitute 1, 1 minus 2 plus 4 will be equal positive 3. When we substitute 2, 8 minus 8 plus 4 will be 4. And when we substitute 3, this will be equal 13. So this will be our table. Now question 3.1.3, we have to draw a neat graph of f of x between these values and also show the turning points in the graph. From our previous table, when x is equal negative 2, y is equal negative 12. So we have negative 2 and negative 12. When x is equal negative 1, y is equal positive 1. So when x is equal negative 1, we have our positive 1 there. And when x is equal 0, y is 4. And this was also our turning point. And when x is equal 1, y is equal 3, which will be somewhere there. When x is equal 2, y is equal 4. So we have 2 and 4. And when x is equal 3, y is equal 13. So we have 13 there. And we also had another turning point. The other turning point was 1,33 and 2,81. So let's also include this turning point. So that will be our turning point, the second turning point, the first one being at 0 and 4. So let's join our points. That will be our first turning point and second turning point. And this will be our graph. Question 3.1.4 states that if x is equal negative 1, 2 is an estimated value of the root of the equation x cubed minus 2x squared plus 4 is equal 0, use Taylor's or Newton's method twice to determine a better approximation of this root. And we have to correct our root to 3 decimal figures. From the formula sheet, we have the following formula that we are going to use. So we have x subscript n plus 1 is equal x subscript n minus f of x subscript n divided by f prime of x subscript n. Our n always starts at 0, and that negative 1, 2 is our x0. And we have to differentiate that f of x so that we can substitute the negative 1, 2. So f prime of x will be equal the derivative of x cubed, which is equal 3x squared. The derivative of negative 2x squared is equal negative 4x. And the derivative of that 4 is 0. Remember, I said that n starts from 0. So we have x subscript 0 plus 1. But 0 plus 1 is just 1. So x subscript 1 will be equal x subscript 0 in the place of the n minus f of x subscript 0 divided by f prime of x subscript 0. We substitute x subscript 0 is equal negative 1 over 2, both in the original and the derived equation. So let's start in the original f of x equation. So we have f of negative 1, 2. The x0 is that negative 1, 2 is equal negative 1, 2 cube minus 2 multiplied by negative 1, 2 raised to the power 2 plus 4. And f of negative 1 comma 2 will be equal and this will be equal negative 0 comma 608, and let's substitute into the derived equation. We have f prime of a negative 1 comma 2 is equal 3 into negative 1 comma 2 squared minus 4 into negative 1 comma 2. So f prime of negative 1 comma 2 will be equal 9 comma 1 2. So now we substitute into that equation, that formula. So our x1 will be equal x0, which is equal negative 1 comma 2, minus f of x subscript 0, which is negative 0 comma 608, divided by f prime of x subscript 0, which is 9 comma 1 2. So our x1 will be equal, this will be equal negative 1 comma 133. Now we determine x2. Remember the formula was xn plus 1. So now we have x subscript 1 plus 1. So that formula, we have n plus 1. But that 1 plus 1 is equal to. So 1 plus 1 is equal to. So we have x subscript 2 is equal x subscript 1 minus f of x subscript 1 divided by f prime of x subscript 1. We just copy these two equations so that we can determine the f of x1. I'm just gonna drop this here. So f of x1, we are determining f of x1, and our x1 is equal negative 1 comma 133, but I'm just gonna substitute negative 1 comma 13. So you guys will substitute the whole negative 1 comma 133. This will be equal negative 1 comma 133 cube minus 2 into negative 1 comma 133 squared plus 4, and f of negative 1 comma 133 will be equal, okay, so this is equal 0 comma 0033. All right, now we substitute into the f prime of x. So this will be equal 3 into negative 1 comma 133 squared minus 4 multiplied by negative 1 comma 133, and this f prime of negative 1 comma 133 is equal 8 comma 35. So now we substitute into that formula. So our x2 will be equal x1, which was equal negative 1 comma 13, negative 1 comma 133, minus f of x subscript 1, which is equal 0 comma 0033, divided by f prime of x subscript 1, which is equal 8 comma 35. And now x2 will be equal negative 1 comma 130, and this will be our answer. Question 3.2 states that a rectangular shell has edges welded from steel bars with square ends. If the total length of the steel bars is 144 meters, we have to find the dimensions of the shell that yields the maximum volume. So the word maximum is attached to the volume. So it is the volume that we are going to differentiate. All these edges are made from the 144 meters steel bars. So when we count the length of all the edges, it should give us 144. So the 144 is like our perimeter. Friends, from here, let's check how many Y's we have. So we have that Y length number 1, Y length number 2, Y length number 3, and Y length number 4. What about the X's? So we have X length number 1, number 2, number 3, number 4 on the right, and on the left, 5, 6, 7, and 8. So we have 8X and 4Y. So the X's are 8. So we have 8 multiplied by X, and the Y's are 4. So we have 4 multiplied by Y. Remember, the total length of the steel bar was 144. So this will be equal 144. So it was 144 meters. Yes. So from here, our volume. So we determine our volume. So volume will be defined as the base area multiplied by height. The base area is X multiplied by Y, and the total height, the height is equal X. So this will be equal X multiplied by X is equal X squared multiplied by the Y. So we are going to substitute. So let's make the Y the subject of the formula and substitute it into the volume. So we have 4Y is equal 144 minus 8X. We divide through by 4. So 144 divided by 4 is equal 36. So we have 36 minus 8 divided by 4 is equal 2. So we have negative 2x. We are going to substitute into the volume. Remember, the word maximum was attached to the word volume. So we substitute into the volume and differentiate. So where there is y, let's substitute the 36 minus 2x. So our v will be equal, so let's distribute that x squared into the parentheses. X squared multiplied by 36 is equal 36 x squared. X squared multiplied by negative 2x is equal negative 2x cubed. Now let's differentiate. We differentiate and equate to 0 because maximum occurs at the turning point. So the derivative of the v will be equal the derivative of 36x squared, which will be equal 72 multiplied by x. The derivative of negative 2x cubed will be negative 6x squared. And now we equate the 72x minus 6x squared to 0. And we take the 6 as our common factor, 6x as our common factor, and our parentheses will open up to 12 minus x. And this will be equal 0. 6x will be equal 0, or the x, or let's just say x will be equal 0, or the 12 minus x will be equal 0. So the x is equal 0 will be inadmissible. So this one will be inadmissible and will be left with x is equal 12. So they said dimensions, and we had x and y as our dimension. So yeah, they say find the dimensions. So we have x and y as our dimensions. So the other dimension that we have to determine is that y. So let's copy and paste In the place of the x, we are going to substitute the 12 in the place of the x, and our y will be equal 36 minus 24, which is equal 12. So x is equal 12 and y is equal 12. And even the y is equal 12, and this will be our answer. Question 3.3 states that the surface area of a snowball decreases at a rate of 6 meters squared per hour. How fast is the diameter changing when the radius is 2 meters? And that A that we are given is actually the surface area. So we draw a circle, and from the center to the edge we have a radius, and from the edge to the edge we have a diameter. So in other words, the diameter is equal twice the radius, or making the r the subject of the formula, the radius is equal the diameter divided by 2. And we are told that the surface area is decreasing at a rate of 6 meters squared per hour. So the derivative of the surface area with respect to time is decreasing, and the decreasing part is shown by the negative. So we have this as negative 6 meters squared per hour. In the place of that r, we are going to substitute the d divided by 2. So we have a is equal 4 pi, and in the place of the r, we substitute the diameter divided by 2, and this will be squared. We simplify, so the surface area will be equal 4 pi, and the d squared will just be d squared. 2 squared will be equal 4, and from here the 4 divided by 4 will be 1. So we have the area is equal pi multiplied by diameter square. So now we can differentiate with respect to time. The derivative of the a is 1, but we multiply this by the derivative of the area with respect to time, and this will be equal pi. The derivative of the d squared is 2d, which we multiply with the derivative of the diameter divided by the derivative of time. We have that negative 6 is our dA over dt. So we substitute the negative 6 here. This will be equal pi multiplied by 2 multiplied by the diameter. Remember that at the end we have to make the derivative of the diameter with respect to time the subject of the formula. So how do we determine that individual d? Remember they said how fast is the diameter changing when the radius is 2 meters. Since our formula has diameter, we have to change that radius 2 meters into diameter. So from here we have to change the radius into diameter. So r is equal 2 and the diameter is equal twice the radius. So in the place of the radius, let's substitute 2. So our diameter will be equal 2 multiplied by 2, which is 4 meters. So in the place of that d, we substitute 4. And we still have the derivative of the diameter with respect to time. We divide both sides of the equation by pi multiplied by 2 times 4, which is 8. So we multiply both sides of the equation by 8 pi. Finally, the derivative of the diameter with respect to the derivative of time will be equal negative 6 divided by 8 pi, which is negative 3 divided by 4 pi meters per hour. And this will be our answer for this final question. Friends, thank you for watching. If you have any questions Drop them in the comment section below. Remember to subscribe, like and share the channel if you find this content interesting.